Welcome everyone. In this video we are going to learn about Euler's method. Okay, so what is Euler method? It is a numerical technique which is used to find the solutions of first order ordinary differential equations. So ordinary differential equation, it looks like this. Okay, dy by dx, first order. So if we want to solve this type of problems, we will go for Euler's method. So it is this one I have already told. So how does it work? It works by using the tangent line at a given point to estimate the value of the function at the next step. That is, basically we will be using the formula of the line. So what is the formula of a straight line? Y equal to mx plus c. So that will be used to find out the value of the next y. If we know the current value of x, then we can predict the next value of y, right? So using the tangent line method, we are going to find the value of the function at the next step. And it does this iteratively by stepping forward by a small amount of age. Okay. So consider this graph. So suppose this is our function f of xy. So we need to suppose we are at this point when x naught, we know that when this is the initial condition given. So x naught is given. So when x naught is this one, y naught is this one. Okay. So we need to know the value of y1. So we will draw a tangent at this point and we will try to predict the next point by what? By using the Euler's formula. We will show you the Euler's formula which resembles the straight line formula. Okay. That way we will come to know the value of y1. Okay. Then here, now suppose when we are y1, that is x1 is equal to this one, y1 equal to this one. Suppose we want to know what will be the value of y2 when the value is x2. Then again we will draw a tangent from here and then we will apply the formula to find out the value of y2. So suppose from here, we are starting from here, x0, and we need to find out the value at x3. So what we will do, we will divide it into h equal parts. So this distance from x0 to x1 is one step size. This one is another step size. So we say this value as h. We will see it in the formula. So this is how by drawing straight lines, we try to predict the next value. So this is the formula I was talking about, straight line formula, yn plus 1 equal to yn plus h into f of xn comma yn. X and yn is the current point, h is the step size as I have told, this distance, then this distance. So it will remain constant, and yn plus 1 is the next point. And f of x and yn is the derivative of the slope at that particular point. Okay, this is the slope. So now let's see one numerical example. So this is an ordinary differential equation. So dy by dx is equal to x plus 1, and it is given that y of 0 is equal to 1. That is, when the value of x is 0, y is equal to 1. So this is the formula, this is the value given, initial value. Step size or h is given 0.1, and up to x we need to find out 0.3. Up to 0.3 means if we start from x equal to 0.3 and h is equal to 1, then how many intervals will be there? 0 from 0, 0.1, 0.2, 0.3. So total from 0 to 1, 1, 1 to 2 to 3. So total 3 divisions will be there. Okay. So first we will try to compute it when at x0, y0. That is when x is equal to 0, and we know that when x is 0, y is equal to 1. So we will put it in the formula. So what we will get? Y naught is 1, h is 0.1, x is 0, y is 1. We will put it in the formula x plus 1, 0 plus 1 is equal to this. If we solve this, we will get 1.1. Then we will go to step 2. That is, we are going to, now what is the new value of x and y? X is now, x will become 0.1 and y1 is 1.1. Again we will put it in the formula and we are going to get this value. Okay. So now at this point, that is at x equal to 0.3. So at that time, what will be the formula? Again we put the values and you will be getting this final value. So what is the value of y at x equal to 0.3? It is 1.362. Okay, so let's go to dev C++ and write down the code. So first of all, we will include the header file. So I am using iostream using namespace std. So this part we will see later. First let's go to main. So here in main, inside main, what are the variables I have declared? The initial value of x0, so it is equal to 0. When we saw the example also, if you see the example also, initial value of x0 is 0 and y is 1. So that's what we are going to put. x0 is equal to 0, y0 is equal to 1, and step size we are going to put it as 0.1. Okay, the data type is double. Then how many steps? That is, we need to find from 0 to 3, right, till x equal to 3.3. So if we divide it by 0.1, we will get 3 steps, right? 0.3 divided by 0.1, so it will be 3. So step size is 3. Then we are going to call the Euler method. So we are passing the initial value of x and y, age, and number of steps. Okay. Now we will go to this particular function. So here is the Euler method. This is the function. So we are getting the arguments x0, y0, h, and steps. Okay. Now here we are declaring two more variables x and y, which will store the values of x0 and y0. Okay. So this is just, I am writing x tab y approximate, like, okay, when you will see the output, just this is a statement I am writing. Then after that I am writing displaying what? X value and y value. Okay. Now the main thing comes from here. So for how many times you are going to perform these steps? The same steps we are going to perform step number of times, right? So this time step number is 3. So when we are in step number 1, we will calculate the value of y, that is the next value of y. So y will be equal to y plus h into f of xy. So what we will get? What is the value of, now when we are entering the loop, that is step number 1. Okay, 0, I equal to 0, 0 less than 3. So we are entering. So what is the value of y? Y is equal to y. So x0, initially we are putting 0, plus what is the value of h? H value is, we have taken as 0.1, and then we are calling the function f of xy. F of 0, 1 we will pass. Okay, sorry, here this is not 0, this is 1. Y value is 1. Okay, here we have given 1 value, sir, right, because y equal to 1. So 1 plus 0.1 into 0 and 1 we are passing to the function, and this function, when we call this function, this part will be activated, right? This one, this is the definition of the function. What it is? Double, that is, it is going to return a double value, double x double y. So it is going to return x plus y, because our function is dy by dx is equal to f of xy equal to x plus y, right? So x plus y, if it returns, so it will return 0 plus 1. So ultimately what is the value you are getting? 1.1 you are getting, right? And then what you are doing? X equal to x plus h. So what will be the x of value? X plus h means next value will be 0.1, because we have started with 0. So next will be 0.1, and we are displaying the value of x and y. So this is the first step. So next step, when we will increment, I value will become how much? I value will become 1. That is we are in step number, second time step. 1 less than 2, again we will enter. Then again we will update this formula. So what is the new value of y? Y value is this one we got, right? So it will be 1.1 plus h will remain same. This time into x plus y. What is the value of x? 0.1, and y is 1.1. So again we will get a new value, and then we will again increment the value of x. So x value will be 0.1 plus 0.1, because h value is equal to this, so 0.2. So this one we are displaying the value of y at 0.1. So like that till 0.3 we will do, and finally we will display the result. So let's run this program. So we will first save it and then go to execute and compile and run. Okay, here we are getting some before what. Okay, here I have written that part. No, let me remove it. Okay, I wrote something to explain, that's why it is coming error. Now you see, so when I have given x equal to 0 initial value, the value was 1. So at 0.3 it is 1.362. So this is the answer. Thank you everyone.